better in English. Well, I think we can start. Carlo and Valeria, okay. So if you're ready, we can start. I think we can start. I just briefly introduce your webinar, your seminar in English. We have colleagues not speaking Italian, so you can give the seminar in English. So good evening, everyone. This is the webinar number 20 of the webinar series on COVID and the economy. So it's quite a long number of seminars in this series. Tonight, we will have two colleagues, Carlo Fezzi from University of Trento and Valeria Fanghella, Grenoble School of Management. They will give us a seminar on the real-time tracking of the impact of COVID-19 on economic activity using electricity market data. As usually, you have 45 minutes for presentation, 15 minutes for 20 minutes if you want for discussion. I would ask a colleague to send their questions using the Q&A function in Zoom. I think we can start. So Valeria and Carlo, thank you very much for your seminar in advance. And so the floor is yours, please.
Thank you so much, Marco. I hope you guys can hear me well. I'm going to share the screen now. Let's see. Okay, hopefully you can all see the presentation well. And thank you so much for inviting us. Also, on behalf of Valeria, I want to say thank you for having us here. I think this series of seminars on this topic, COVID economics, is such a timely and interesting way to discuss about such an important topic right now. So I'm very grateful for being here, able to present our work. And this work started when Valeria was finishing her PhD here at the University of Trento, and now she moved to greener pastures. She's at the School of Management in Grenoble. And really, what I'm going to talk about, what we are going to talk about today is written in these two different works. One, which was published in August in Environmental and Resource Economics, and the other one, which is a working paper, which is submitted now, and hopefully we will see maybe published soon. And just to give you a little bit of a roadmap of this talk, I'm going to give you a few background notions, so we are all on the same base. I will talk about very briefly about the literature we hope to contribute to, and then I will present the methodology that we developed. And then I will leave the floor to Valeria, who will talk about the results and draw some conclusions as well. And really, if we want to summarize this work in one slide, so what we're trying to do here is to address an issue which has been there for quite a long time, but that you can really feel its importance when there are situations of crisis such as COVID-19. And the issue is that is the way is the way institutions measure GDP. Normally, GDP indicators are published quite slowly, in a sense that typically they are published with a delay of 2-3 months. So if we want to know the GDP of the first quarter, we're going to know that in April, May, usually. Okay, so with a few months of delay. However, in a situation of crisis, such as the one induced by the COVID-19, or also situation of crisis induced by, for example, natural disasters, or even financial crisis, we would like to really know how economic activity responds as soon as possible. We would like to be able to track in real time the behavior of economic activity. And we argue here that we can do that if we collect and analyze properly information on electricity. Why? Because why we are proposing electricity? Because electricity is a necessary input for practically all economic activities, and because we have information on consumption of electricity, which is available in most developed countries practically in real time. So there are markets where electricity is traded, and on the next day we have the precise information of all the electricity that was used on the previous day. This is true for Italy, France, Germany, United States, for many, practically all developed countries in the world. And also we have, for some countries, Italy is an example, we have information at a macro regional level. So we didn't do it here, but we could run analysis at the, for example, for the north of Italy, separate from the south and central part of Italy, different parts. So different macro regions. And so we show how we can analyze this data and use it as a proxy for GDP, so to track in real time the impact of shocks. So, and obviously we are going to do an application to the current pandemic. And before I want to try to persuade you, before illustrating the methodology, I want to try to persuade you that this methodology works. And I'm going to show you some stylized facts. And for example, here is data from the Great Recession. So the financial crisis between years 2008-2010, and here we have the recession and then the rebound phase. And each point represents an year and a nation and a country. So here we represented different European countries and also some extra-European countries such as United States and China. And on the y-axis, you have the change in GDP. So you can see here, we have a big drop in GDP. This is the crisis. And then here we're going to have the rebound. And here, the change in annual electricity consumption. You can see how there is a really strong relationship between these two quantities, and with a coefficient of correlation of 0.91. So just looking at electricity data, we can already, even on just simply using yearly data, we can see how strong is the relationship between these two variables. One thing I have to say, though, is that this relationship is very strong in the short run. However, if we would measure this relationship in the long run, so I don't know, for example, the change in electricity in the past 10 years and the change in GDP in the past 10 years, then it would be much more problematic, because you would have changes in technology, in energy efficiency. These sort of things will somehow reduce the strong correlation between these two variables. However, if you use it to monitor short-run shocks, then the correlation is really strong. And this is another stylized picture, but here we are already starting to delve into the COVID-19 impacts. And here we can see consumption of electricity consumption, daily electricity consumption in Italy during 2019 and 2020. And we can see that, you see, this is in gray, we have 2019, and we can already start to appreciate all the typical feature of electricity consumption. You see, this seasonality is the weekly cycle, with drops during the weekends. And also we have a much smoother yearly cycle with a little bit higher demand in winter, when electricity can be used for heating, but also a much higher peak in the summer, when definitely is used for cooling, for air conditioning. And here we can already see the dip in August, because of the holidays. So we can really start to see how electricity consumption is really correlated with the activities of the population. This dip in August, there is another dip here with the Christmas holidays, and obviously the weekly seasonality. And then we see suddenly, I mean, straight away, we can see the impact of COVID-19. We can see that in year 2020, basically electricity demand was following pretty much the same path that it was following in 2019. And then at the beginning of March, we see how the two series depart from each other. You can see this big drop as a response of the restriction of the non-pharmaceutical intervention introduced by the government to stop the spread of the virus and all the restrictions on economic activities. We can see how we have this really, really strong drop in electricity demand. And then with the removal of the lockdown and the reopening of the economy, we can see how electricity starts to, well, we can see how the gap between the two series starts to become smaller, and the electricity demand starts back towards the path that he had in the previous year. So here we already see a little bit in an illustrative way what you are trying to do in this work. We're trying to measure the impact on economic activity using electricity market data. Now, which type of literature we are going to try to contribute? The first branch of literature is the literature on nowcasting GDP with high temporal and spatial scale. And here we have this really nice paper by Henderson et al. On American Economic Review, where they use data on light, on night light captured by satellite to measure GDP at a very refined spatial scale. Very, very cool paper. Or other papers where they try to use different indicators to construct predictions or proxies for GDP at a very fine temporal scale. So similar to what you are doing here. And this type of literature increased a lot with the COVID-19 because we need to understand the economic impact of this non-pharmaceutical intervention in order to understand which are the trade-offs between stopping the virus and preserving the economy. So there is a lot of effort studying the impact of the different lockdown or different business restrictions that governments across the world have introduced to curb the spread of COVID-19. And therefore, there was a strong growth in this literature, trying to understand the impact on economic activities as soon as possible to be able to track in real time those impacts. And here there are just a couple of papers, but there are many more. And the second strand of literature is, of course, also another very new literature, unfortunately, is the literature on the impact and the trade-off of COVID-19, indeed. And there are papers that look at those impacts and trade-off from a theoretical point of view, such as the paper by Acemoglu and co-authors, or then there are other papers that estimate the empirical impact of different MPIs in different parts of the world. For example, these other two papers. And so which type of data are we going to use here? We are going to, the data on electricity demand comes from the ENSO-E, which is basically a website that collects all the data from the different power system operators in Europe. And so we selected 12 countries, Italy, France, Germany, and several other European countries. And we have data we have hourly day-ahead electricity load. Electricity load is basically the electricity consumption. And we have this information for the years 2015 to 2020. And then of course, we want to include all the important drivers of electricity consumption, temperature, and for example, holidays, and various other drivers, which we're gonna mention in a second. And then another important variable that we will use to convert electricity demand changes into GDP, which is the share of residential load. And then various other sources of data, which Valeria is going to talk about when she will present her part of the analysis. comparing our results with also health impact of COVID-19. I'm just going to present a little bit the methodology, and so in order to understand what's the shock, what's the impact of the shock on electricity demand, the shock being COVID-19 and the related policy responses, we need to isolate the impact of such shock. So we need to remove the effect of all the other drivers of electricity demand, such as weather holidays, special events, and also the long-run drivers, which I kind of introduced before a little bit, which can be technology, prices. Prices are a long-run driver because just regular consumers are not exposed to the price fluctuations on the day-ahead market. They have electricity based on long-term contracts. But in the long run, prices will affect consumption. And therefore, we need to take that into account. So we need to remove all these drivers in a way to isolate the effect of the shock. So this methodology that we developed has several steps. There's a pre-filtering first, then we estimate the impact on electricity. We estimate what that means in terms of GDP. And then also we have a series of in-time placebo tests, which I'm not sure that there is time to talk about, but if there is, we basically want to make sure that our methodology is not picking up spurious variation. Okay, so we want to make sure that, for example, if we simulate a shock in another period of time, then we estimate a non-significant effect. And we do that in the paper. We show that that's working pretty well. So the pre-filtering is composed by two steps. In the first step, we want to remove all the short-run variables, the short-run drivers. And here we have our relations where Y, which is electricity demand, on the daily basis. So we already aggregated the hourly demand into daily. So here YT would be electricity consumption at day T, which is a function of average temperature at day T. And also this is a nonlinear representation of temperature. Basically, we allow a V-shaped effect, because electricity is used a lot for heating and for cooling. And then we have got 4 dummy variables which represent the weekly seasonality. And we remove the weekends from the analysis because we want to concentrate only on the days where most of the demand is for economic activities. And also we have a series of different dummy variables to take into account different type of holidays, Christmas, Easter, and also different other type of holidays that we generate for each country. So that's the first step, and we estimate this first step only in the period of time before COVID-19. Okay, if we estimate also this during the period of COVID-19, this impact will be somehow biased by the impact of COVID-19. So we estimate this before COVID-19. We use these parameters and subtract these, we filter out this source of variation on the entire series. And then in the second step, we filter out the long run impact. And here we do a very, very simple approach. Again, before the shock of COVID-19, we calculate simply a fixed effect. So an yearly fixed effect is capturing the average level of prices, but mostly really the average level of technology present in that year. And again, we filter this effect out from the series. So I just want to show you how it looks like. So this is a series for Belgium. Here is the data before pre-filtering. So you can see the weekly seasonality and everything that's going on. And here you can see the series are closed, and then they get separated far apart, and then they get close together again. But also here you see, even before COVID-19 struck, the level of demand the level of consumption in Belgium was quite lower than the level of consumption in 2019. You can see it here. And this may be because maybe in one year was colder than the other year, or maybe you have more holidays, or maybe you have different energy efficiency measure and things like that. So we really need to correct for that. It's really important. And here is the series after the pre-filtering, and we can see how now, before the introduction of the lockdown in Belgium, you can see that now the series are really one on top of each other. So you can really see that the pre-filtering method, at least in my opinion, seem to have dealt very well with this issue here. You can see how there is a separation, and then they go back together. Okay, after the shock is finished. And so this is for the pre-filtering. After the pre-filtering, we want to estimate the impact of the shock. And again, we use a very simple fixed effect model. And here we have the filtered load time series, so our filter demand. And we have a series of weekly fixed effect. These fixed effects are going to capture the remaining seasonality. So these are 54 fixed effects. They're going to capture, for example, seasonality related to the change of the hours of daylight, or other type of seasonality that we haven't included before. And then here, this is the key parameter of our approach. These are interaction effects between the weekly fixed effect and year 2020. I'm sorry, there's a mistake, of course, in year 2020. Okay, so this fixed effect will represent the effect. What's difference? What's left? That variation that's left after we remove all these sources of variation, they represent what is different in 2020 compared to all the other years. And what is different after we removed all of these drivers is basically the shock. Okay, Valeria is going to show you that's what remains, is the shock of COVID-19. And finally, to have correct inference, we allow the parameter of we allow the error term to have ARMA PQ representation. So we estimate the model with maximum likelihood. Something I forgot to say is all the pre-filtering is estimated with ordinary least squares, and this is via maximum likelihood instead. So okay, so after we estimate this model, how do we calculate the impact of COVID-19 on electricity demand? We can indicate with LT, for example, and the percentage impact is going to be the prediction from our model, and then the prediction for our model when all these interaction effects that I mentioned before are set to 0. If all these effects are set to 0, basically is the prediction, is the counterfactual, is what electricity demand would have been if we wouldn't have COVID-19. What electricity demand in 2020, sorry, would have been if you wouldn't have COVID-19, divided by, again, the counterfactual. So this is the percentage impact on electricity load. Okay. And finally, the last step of our methodology is we want to be able to say what this means for GDP. However, we care about electricity demand, of course, but we care more about GDP. And we make a very simple assumption, very simple, and then Valeria is going to show you how this performs. A simple assumption is that all the reduction in electricity, all the drop in electricity comes from the productive sector. So the residential was not affected by the lockdown. Sorry, not by the lockdown, by the restriction. Only the productive sectors are affected. However, so during regular days, so during days when we don't have the lockdown, this is the formula. So GDP is just the percentage impact. The percentage impact on GDP is just the percentage impact on electricity times this part, which represents the shares of electricity that is not that is not consumed by the residential sector. Okay. During lockdown days, on the other hand, we use some recent estimates of the International Energy Agency that says that actually during lockdown, residential consumption increased. So during lockdown days, it increased by 40%. So we just assume that the share has to be of residential consumption has to be multiplied by 1.4, so plus 40%. And we just apply this very simple formula to calculate the percentage change in GDP in basically in each week of 2020, which is due to the shock of COVID-19 and the related policies. Now I'm gonna leave the floor to Valeria, who is gonna show you, finally, after all this boring presentation about the methodology, she's gonna show you the interesting part, so the results.
Thank you, Carlo. Okay. Can you see my screen? Can you hear me?
I cannot, yes, you can.
Okay, thank you. So I'm on the wrong slide. Okay, there you go. Yes, here the results, and we continue with the example of Belgium that Carlo already introduced before. And so here we have the estimated electricity impact for the whole observation period that goes between January and August. And as you can see, we have 3 different areas in this graph. So here on the left, we have the pre-outbreak. Here we have the electricity impact before that outbreak. And what we did is that we didn't fix these parameters to be 0. But as already Carlo said, we estimated them as a first in-time placebo test. Because, of course, the electricity consumption in 2020, before the outbreak, shouldn't be different from the consumption of the previous years. There are no reasons why it should be different. And here is our data, for example, for Belgium, but in the paper we report the results for all the countries. We see that this in-time placebo test is passed because all the consumption, the weekly consumption before the outbreak is significantly equal to 0, not significantly different from 0. And then we start seeing a significant drop in consumption when the lockdown was implemented in mid-March. But however, we also see a gradual resumption of electricity consumption and of course of economic activity when the restrictions were lifted in mid-May. But what is more interesting, as already Carlo said, is the impact, the economic impact of the pandemic, rather than the impact on electricity. So here we present the results for 4 countries that represent a heterogeneous spectrum of the level of exposure to the COVID, and as well as of policies implemented. So I start with Belgium and Great Britain, and then I will go to Sweden and Denmark. So Belgium, we already saw the results for electricity in Belgium, and the results for the GDP, of course, follow a similar path because we saw that the transformation is quite simple. So the impact follows a U shape, which is consistent with the temporary economic shock down. And we see this kind of path for many, for most Western and Southern European countries like Italy as well, but Spain, France, also Germany, all those countries that implemented a lockdown when the outbreak exploded, let's say, but then lifted. So, but of course we see different intensity in terms of GDP impact, but the shape is very similar across all these countries. Great Britain instead is a bit different, is quite different, because it had a similar initial exposure to the COVID as Belgium, in terms of a number of cases and rate of infection at the beginning in March. But Great Britain followed a quite different strategy, because at the beginning, at least, they tried to pursue herd immunity. But in the end, it didn't work. So they had to implement a very strict lockdown, but they did it later compared to other countries. They did it only at the end of March. And what you can see here is that the lockdown that they implemented here was much stricter. In fact, it causes a reduction for some weeks that go to even minus 30% of the GDP. And we also see that their lockdown was longer compared to other European countries. For instance, for Belgium and Italy, it was 8 weeks, whereas for Great Britain, it was 12 weeks. So we see that Great Britain failed to coordinate with the other European countries, because they implemented the lockdown later, and they also lifted the lockdown later, because in mid-May, most European countries reopened their economies as well as their borders. So they could somehow restart their economies in a coordinated way, whereas Great Britain couldn't do the same, because their lockdown lasted until June. And we see that they have very high losses until the end observation period and we see only signs of recovery in August, at the end of our observation period. Going to Denmark and Sweden, these two countries are a bit different from the previous two, because their initial exposure was much lower in March. But these two countries followed very different policies. So Denmark was one of the countries that introduced earliest the lockdown. I think just after Italy, there was almost Denmark, even if they had very few cases. And this allowed them to implement a very light lockdown. Indeed, what you can see here is that the losses at weekly level are almost not significant. But if we calculate at monthly level, then we see significant losses of around 5% between March and May. But still, the 5% is much lower compared to the 15 or 30% that we saw for Belgium and Great Britain. Instead, Sweden had a similar initial exposure of Denmark. But as you can see, there are no the lines for lockdown starts and lockdown ends here, because Sweden was the only European countries that did not implement a lockdown. So they really pushed herd immunity. They relied on individual responsibility mostly. And so what we see here is a quite different path compared to the other countries, because for the others, we see losses from March on. We do not detect any loss at the beginning when the other countries were implementing lockdown in March, but we see that they start losing around April, and significantly, like more than Denmark. And this is because the state of the state of economy doesn't depend only on the country's policies, but rather there are also other shocks that need to be considered. For instance, there are demand shocks, like people that change their behavior. Even if they are not required to stay home, they might stay home as well anyways, especially if they are at risk. And also, and most importantly, there are also international spillovers. So even if Sweden didn't close the economy, let's say in April, May, they still lost, but maybe because they had their neighboring countries that were in lockdown. So they still they were still exposed to these international spillovers from other countries, even if for themselves they didn't close the economy. And in this graph, we introduce it to discuss, let's say, the reliability of our estimates, as Carlos said. And here we compare our estimates for the first 2 quarters with the official statistics published by OECD for the first 2 quarters of 2020. And here on the x-axis, we report our estimates, whereas on the y-axis, we report the estimates by OECD for the same 2 quarters. And as you can see, we have a very high correlation between our estimates and the official ones, which somehow reassure about the reliability of our results. This is, of course, an ex-post comparison. But the main difference between our estimates and the official statistics is that our estimates can be really updated almost in real time, because electricity data are available almost in real time and we just need them. Whereas official statistics, as Carlos said at the beginning, are usually available with a few months of delay. And also our estimates are much more disaggregated, so they allow to follow the path and the shape of the shock. Whereas if you just look at the quarter GDP, you don't see where the losses were higher and whether specific policies caused greater losses than others. And going to the last graph here, we compare to the economic and the health impact in order to contribute, let's say, to the discussion about the presence of a trade-off between these 2 dimensions. And in this graph, you see all the countries of our sample. And we have different dimensions, as I said. So the size of the bubbles represent the economic impact, so the GDP losses that we estimated for the whole observation period following the pandemic. On the y-axis, we report the initial exposure to the COVID, which we measure as excess death in April. Why do we measure it like this? So we measure excess death. So we measure the health impact as excess death, which means the excess death in 2020 compared to the same the average number of deaths for the same period of the previous 5 years. And we did so because in order to do cross-country comparisons, we couldn't really use official statistics because there are too many differences considering the testing policies. And we used early April because the development of the disease takes a few weeks, considering also the incubation. And so the death in early April can gives an idea of the exposure, of the rate of infection in mid-March, when the COVID-19 was declared a pandemic by the World Health Organization. And on the y-axis, we have the overall mortality for the countries, which represents the overall health impact for the selected countries. And so what you can see is that there is a positive relation, of course, correlation between higher initial exposure, as we can see for Italy and Spain. They had higher initial exposure and also higher overall mortality and also higher losses compared to many other countries because they had less time to prepare. Whereas countries down here had more time to prepare, so to implement an early lockdown. So they had lower overall mortality, and overall the size of the bubble is slightly lower here than on this side of the graph. And this relation is represented by this line here. But what comes out from this graph is the presence of 2 outliers that are Sweden and Great Britain, and that faced much higher overall health impact compared to countries with similar exposure, like for Great Britain compared to Belgium, Netherlands, and France, and also Sweden compared to these countries down here. And of course, this might be because of countries' characteristics like population density, quality of the healthcare system, or other factors, of course. But the fact that these are the two specific countries that are outliers makes us believe that it's their unusual, unconventional policies that made them differ so much compared to all the other European countries. That means the fact that either they tried or they really pursued the herd immunity strategy made them differ so much and perform worse than all the other European countries. Okay, so going to the conclusion, with the study, we developed a methodology in order to track in real time the short-run economic impact of shocks. And as Carlos said, our methodology is based on electricity market data. And here we applied it to estimate the effect of COVID-19 pandemic on GDP, but it can be also used for future, hopefully not, but future shocks. As we said, as we have seen, the estimates are quite precise for official statistics. They are, the correlation between our estimates and the official statistics is quite high. And they are also robust to different in-time placebo tests that we can discuss at the end if you want, but we presented them in the paper. And they are, but our results are more disaggregated and up to date. And some take-home messages from the first wave of the pandemic. At country level, we have seen that countries with higher initial exposure faced higher economic disruption and also worse economic health impact. Whereas those countries that managed to implement an early and light lockdowns reduced both economic and health impact. And we have also seen that avoiding a lockdown does not prevent economic losses and also worsen the health outcomes, as we have seen for Sweden. But why they didn't? I mean, why not implementing a lockdown doesn't prevent from economic losses? Because we have already discussed this, but there are differences between local and global trade-offs. So what neighborhood countries are doing also affect a country's economy. So the economy of a country doesn't depend only on its own policies, but also on shocks on real and financial markets. And finally, what seems to be the most effective short-run strategy for both health and economic outcomes is the introduction of a coordinated introduction on early and light lockdowns, which can be quickly relaxed when infection rates are under control. Okay, thank you for your attention. We are here for questions. Here are our contacts and the references for the papers where you can find.
Thank you, Valeria and Carlo, for this really interesting presentation. I think there will be many questions from the floor. Not yet in the, present in the Q&A section. Sorry. I think I can, waiting for questions, I can start with a very silly question on my side. So I just was wondering if because you use electricity data, if the sectoral composition of the economy can have some, influence on the connection between the variables that you use for forecasting the GDP. Silly, yes, just a simple question.
Shall I take it, or you want to take it, Valeria? I'll take it. So that's a really, really good point, actually. We used a really simple approach. So the only difference between countries in the way we translate electricity demand into GDP is that little parameter R, which represent the share of the electricity which is consumed by the residential sector. So it doesn't really matter if there is a lot of industrial sector or if there is a lot of commercial sector, say. What's really important is that is the size of the residential sector for this translation. I mean, admittedly, it's quite crude, but it seemed to work pretty well when we compare it to the official statistics. So we were kind of happy with that. Mm-hmm. I guess the model, when the model filters out the impact of weather, holidays, and all the other things, it already captures in a reduced form the fact that there are more of a certain sector in one country than in the other. All these models are separately estimated in the different countries. So each country has its own model, right? So we don't include explicitly the share of electricity consumed by the different sectors of the economy in each country, even though it could be an improvement. Maybe it could lead to even better estimates. At the moment, we just use a very simple approach. It seems to work well, though. So yes, that's a possible way to improve the model. Thank you.
So thank you. So I would ask you, colleague, to please don't be shy. Please ask questions if you have. Again, while we are waiting for questions, someone asked me if you can, make available the paper. I think you have, if I got it rightly, in the last slide you presented the website where we can download the paper, if I'm right.
Oh, yeah, I'm just sharing it. It's yeah. So one paper is published, is on ERI, Environmental Resource Economics, and the
other one is a working paper.
And the other one is a working paper on ArcSave. Yeah, and yeah, but we can. We can obviously share it if
yes, of course,
anyone is interested.
Yeah. I asked about the paper, so if you can send me the PowerPoints and the working paper, or the paper if you want, we can upload in the website of the Società Italiana degli Economisti for sharing.
Yeah, sounds great. Even the published paper is open source. Open access, and so anyone can access it. So yeah, I'd be happy to share that. Yeah.
So,
but there is a question.
There is a question. How did you deal with the fact that data is reported in different frequencies?
Yeah. So thank you for your question. So the electricity data is all in the same frequency. So it's like, it's hourly for each different country. And then we aggregate it on a daily level. And the other data, it depends. Well, the temperature data is, again, on the daily level. So the frequency matches. And then, the others are really some dummy variables that you can play with as much as you want, really. And then what else are like the share of electricity when we do the conversion? That's just constant, so it doesn't really matter. So really, most of the data is on the daily level. And otherwise, if you have some monthly information, you can just assign all the days in a certain month to that variable. That just doesn't really, as long as you translate everything in the frequency of your dependent variable, that's going to work, right? I don't know if I forgot something. Also the excess depth is on the weekly level, but that's an aggregate comparison, right? So we just calculate all the effect at the end of our sample. So by the end of August. So again, the time frequency is not really so important there. I don't know. Maybe I forgot something. Do you want to say something, Valeria? Or
no. Electricity data were sometimes 15 minutes, 30 minutes, 1 hour, but then we just use them at daily level, so it wasn't a problem.
Good point. Yes. So the electricity data is in some countries on the hourly level, some countries 15 minutes, some countries half an hour. We just don't really care so much because we aggregate on the daily level. Thank you.
So Valeria and Carlo, there is another question for you. I don't know if you can see on the Q&A.
Yes.
You want me to read, or you can go to the question by yourself? The increase in the use of electricity in the public sector can create a distortion in the share of GDP that is not revealed by the estimation.
Mm-hmm. Do you want me to reply, or Valeria, you wanna?
No, if you want to.
Okay, so yeah, I mean, it's so yeah, I mean, it's an issue potentially. I think now I don't have the figures on top of my mind, but I think the total share of electricity consumed by the public sector, I don't think is that big, right? I think Valeria knows that better than me, but in different countries,
yeah, it's true, it's not that big.
Wasn't that big, right?
Yes.
I think industrial was really big, commercial, and residential. Those are the three really big, right? And so, yeah, I mean, it's a potential concern. I agree with Alessandro, who's asking this question. And sorry, maybe I should have read the question. All right. So Alessandro is saying, thank you for the presentation. I have a question. Can, for example, the increase in the use of electricity in the public sector, which had an increase in activity, create a distortion in the shares of GDP that anyway is not revealed by the estimation? Thank you. So I was saying, yeah, I mean, the share of the public sector is not probably that significant, but is a potential concern. I mean, I agree with Alessandro. And yeah, the only thing, again, really, I think is a potential concern, a potential refinement that one can do, right? Again, with this R, we had this, we were and using this R parameter, so the share of the electricity from the residential sector, we kind of try to capture the fact that not all sectors were affected by the lockdown, or not all sectors were equally affected by the lockdown. And but yeah, definitely you could do a refinement for the public sector as well, trying to figure that out. It doesn't seem to generate a big bias though, again, because of the fact that our results, when we aggregate our results for the first 2 months, for the first 2 quarters, so the first 6 months of 2020, we get estimates that are very close to the official one. So we think, okay, that's pretty good, but still, obviously, it can always be improved. So this is another point of improvement for sure. Yeah.
So again, waiting for another question. I was wondering if this factor that you use to correct the consumption of electricity, that 40%, if I do not remember, if I do remember correctly, is it set the same for, I mean, all the countries and with the same timing, just, I mean, as a unique variable to be used for across all the situations?
If you want, I can take this one. Actually, the 40% was an average estimate by International Energy Agency for all Europe. So we looked for a country level percentage, but we couldn't find it. So we just used it because it was just available at the average level. And we only applied it for the weeks with the lockdown, with the strictest or with lockdown. So for each country, we applied it in a different period, considering the weeks of lockdown. It's not that we applied it to all the countries at the same time.
Okay, so same but different periods.
Yes, exactly.
Thank you. So, any other question? Or comment? No, I don't see other question. So, Valeria and Carlo, I don't know if you want to add something at the end. I personally, I've enjoyed your presentation a lot. Really nice paper, really interesting paper. So I don't know if you want, I mean, just exploit the last two minutes of our time to add something.
Well, the only thing we didn't show is the placebo test. But so the idea behind the test is to just use the same approach in different times when we know there was no shock and we should estimate no significant effect. So for example, Valeria kind of mentioned it already, but I'm trying to travel towards, so we can see here. So you can see here in the pre-outbreak, in the pre-lockdown period, we see that basically there is no significant effect. So this is a sign that the model is not picking up some strange behavior of year 2020 here or here. Now, here it's picking up nothing significant. So it means that the model captured well all the determinant of electricity demand. And we did this as well for year 2019. So we just pretended that the outbreak of COVID-19 happened in 2019 and just see which are the coefficients. And then we basically, for all countries but one, which is the one we are less sure about, which is Germany, but for all the other countries, we basically got all these coefficients to be non-significant, or at least compatible with the significance level. So maybe 5% of the coefficients were significant at the 5% level and 10% at the 10%. So that's another, I think, aspect that is important of this methodology. There have been a few other papers looking at electricity demand and how the COVID-19 affected electricity demand, using electricity demand as a proxy for economic activity. But we feel that none of them really developed a methodology that can be applied in a consistent way and robust way with all these tests as well in different countries and in different situations, really. I mean, it can be extended beyond COVID-19. So yeah, that's maybe the only, I don't know, Valeria, if you want to say something else, I'm not sure.
Sorry, I was reading that we have another comment on the
yes, in the meanwhile,
wireless.
replied to your explanation. Also, I believe that, as you say, this does not create a distortion in the difference between your estimation and the OECD estimation, but probably can say something on the proportion of the economic weight of the pandemic on the economic actors. So thank you again, very interesting work. So, okay. I don't see other questions, so I want to thank you again, Valeria Fangella and Carlo Fezzi, for your really interesting, really nice presentation, a nice paper. I thank you all the participants to this webinar, and the next meeting, the next webinar will be in 1 week, so next Thursday at 5 on a regional perspective. The title of the paper is COVID, that will be presented is COVID-19 and Italian regions and the regional value chain approach. And we have 9 speakers, so a long list of presenters. So again, thank you everybody for attending this seminar, this webinar. Thank you, Valeria Fangella and Carlo Fezzi, for your presentation.
Thank you so much.
Thank you.
Grazie. Buonasera a tutti.